Now we're going to do a Python implementation of the Dijkstra's algorithm. And the first thing we do is we're going to import heap queue. And this is for basically the priority queue or the mini heap that we're going to be using in the algorithm. And we're going to define the function here. So I'll just call it, it's called Dijkstra, and text in a graph in the start node where we're starting with when you're doing this. So the first step we're going to do is we're going to initialize the distances from start to all the nodes, and we're going to initialize it as infinity. So you can start with distances, and this is going to be, so you have node. So this is how we initialize the distances to infinity. And so it's going to be that for node in graph. So we're iterating through the graph and getting the distance that we want. So from here, the next thing we're going to do is we're going to check also distances. So the start distance, we initialize the value to 0. Start again the same way we did with the algorithm. We initialized to 0 once we determined our start node. So we're going to have that to start with 0. And then the next thing we're going to go ahead and do, okay, you see there's this error because the closing parenthesis is supposed to be here and not there. Right. Now, the second step we're going to do is we're going to use the priority queue to track the shortest paths. And how we do that, we'll just so it's priority queue. And so this is going to be basically, we specify the distance and the start. So distance and the node. So the node is going to be the start node is what we're starting with, like that. So with that, we've basically started tracking the shortest paths, and so we're going to just check while priority queue. Then from there, we're going to go ahead, and the first thing we'll do, like you mentioned, is we're going to pop the node with the smallest distance from here. So, and how we do that, we're going to basically use the heap queue, but we're going to store first of all the current distance and the current node, and how we store this. So or rather how we do this. So heap queue dot heap pop. Okay. So yeah, so heap pop, and you're popping the priority queue like that. So that way we pop the node with the smallest distance. And then now if a longer path is going to be found, we're going to skip that longer path. So how we do that, we're just going to add a condition. So we'll just check if the current distance. So we're going to check if the current distance is greater than. We check the distances that we have, but now the current node. So if the current distance is going to be greater, we're going to continue. So we're going to basically skip if the path is longer. Then we're going to go ahead and start exploring the neighbors and update the distances. So for that, we'll just do some iteration. So check for neighbor and weight in the graph. We're going to go ahead and start calculating the distance first. So we'll calculate the distance. And how we do this is just current distance plus the weight. That's how we calculate our distance. Then we're going to check now if a shorter path is going to be found. We'll update the shortest path and then add it to the queue. So we'll just check. We'll use the if statement that we did earlier. So we'll check if distance. So if distance is less than distances of the neighbors, then we're going to update the shortest path. So how we update? We just say distances, then we check neighbor. So here is when we are going to update the distance, rather we're going to update with the distance. Then from there, we're going to add to the queue, and how we do that, we use the heap queue dot heap push. So what you're adding is the priority queue. Here's the first argument, priority queue, and then I'm going to add the distance and the neighbor. So distance and neighbor. Then after doing all this, the last thing we're going to do now is we're going to just go ahead and return the distances. So let's return the distances. Again, this is good. The distances that we're returning here, this is going to return the shortest distances that are there. Right, so now we can go ahead and test this out and see if it works. So the first argument that our function was taking in is a graph. So we need to define a graph here. So we're going to have a number of nodes. Let's start with A, and we're going to give it some distances here. So the neighbors of this are going to be B, and okay, what am I doing? They're going to be B, and B has a distance of 1. Then we're going to have C, and C has a distance of 4. It's basically what the one that we did on the this one here. This is what I'm trying to implement. So and then we have B. B is going to be the neighbors of B are C, distance is 2, and D, the distance is 5. Let's go ahead and add C and D. We're going to have C here, and for C, it's going to have its neighbor is going to be D, and the distance is 1. And then we have D, and D is not point. There's no, it's not going anywhere from there. So this is our graph. Then to find the shortest paths from node A, we just need to first of all call the Dijkstra's function, and we're going to store the distances to a variable. Let's call this variable result. So we call the Dijkstra function, then we pass in the graph, and then we pass in the start node, and the start node in this case is A. Then we can go ahead and print our result. So once we print the result, we're going to get like what we found here, the shortest paths that we found, 1, 2, 4. We're going to have all those. So let's go ahead and first of all run and see whether it works. Python 3 dijkstras.py. It's saying, okay, there's an error somewhere. This is line 2. Okay, don't need this. Let's run it again. Awesome. Yeah. So now you can see the shortest paths that are there, and that is basically what the Dijkstra's algorithm is. That is its implementation. Like you've seen in some applications of this in the real world. For example, if you're planning the shortest route for a delivery service, so a service like Uber or Uber Eats, the Dijkstra's algorithm helps calculate the fastest routes to all the delivery locations that are there. So, that's all. Thanks for watching. I'll see you in the next one.